you said you made the right positive.
Okay.
-3 units. I know my total is -2, this has -3, so what does this momentum have to be in order for the sum of those to be this? So -3 plus x is equal to -2. That's the math problem we're working here.
1.
So the momentum of mass 2 final is 1, positive 1. And that's equal to its mass, 5 kilograms, times its velocity, 2 final. So the math problem we're now dealing with is 1 is equal to 5v, so v equals 1/5, yeah, 0.2. It is a positive answer, which means that the 5 kilogram mass is going off to the right at 0.2 meters per second, or 1/5 of a meter per second. The power of momentum. All right, questions to here. I want to do one more similar to this. We'll keep the same initial setup just so that we have the same total momentum. Questions before I start erasing some stuff? F stands for final.
And that's the other.
So after the collision.
And, oh, yeah, for D, that, you said that could be anything as long as it doesn't like affect what is it, the international something?
Oh, yeah, as long as they're not using a unit that's being used by something else.
Okay.
So the answer to wall 2 would be, or like 2 would be positive 1 kilograms per meter per second.
That the total momentum, the mass 2's momentum after the collision is positive 1 unit, and its velocity is 0.2 meters per second.
Okay.
It helps if I stuck the 0 in there. Other questions right now? All right, so let's keep that. We don't need this anymore, so we have that. So we have these two heading towards each other, except this time when they hit, they're going to stick together. All right, they're going to stick together when they collide. Now, what is their total momentum after the collision?
Is it the same?
Yes, it is. It's still -2. All right, I know that P final is equal to -2 units. And that's got to be equal to the mass times velocity. So if they stick together, what's the mass now? Times whatever that final velocity is. So my math problem is -2 is equal to 8v. That's my math problem. So what does v equal? Fraction or decimal form. Yes. Negative 0.25 units. Absolutely. So they don't stop completely. It does, they both get really slow, and they are moving off to the left.
What is it equaling to?
Which,
What is it equaling to? Is that a V?
that's a V there.
Alright.
That's supposed to be the same symbol as this one. It's the V with a vector symbol for velocity, and then the F, subscript F for final.
Okay.
All right. Let's make it look more complicated. It's not gonna be more complicated, it's just gonna look more complicated. I have some object of some mass m going off to the right at some speed v. I have another object of mass m going towards to the left at some speed v. What is the total momentum at this point in time?
M times V. M times V.
That would be a step in the right direction. It's not the total though. All right, so what is the we'll call this mass 1 and mass 2. So the momentum of 1 initially would be, now Isabella.
M times V.
Yeah, mv. The momentum of the second mass before the collision, there's initial, would be
MV.
Negative.
yes.
Oh, yeah.
This way is positive because Isabella said so. So this would be negative mv. So the momentum final, the total momentum final would be, or actually let's do it step by step. What's my total initial?
Zero.
Like you mean it,
Zero.
0. I have no idea what m and v are, but that's the negative of it. If I add them together, it's a puff of smoke.
Mhm.
There's no momentum in the system. If they stick together, so if stick together, then what's the total momentum after the collision?
Zero.
Yep. If they don't stick together, what's the total momentum after the collision?
Zero.
Still 0. And if they do stick together, what's going to happen? How fast are they going after the collision?
Zero.
You're on a roll. Yep. Because there's no momentum when they stick together. Now I have this giant mass with a total momentum of 0. I know mass isn't 0. Velocity has to be. And you did this in the lab, or at least it should have happened, where you, in the situation where the carts had the same mass, so this would be parts A and C, and you push them towards each other at roughly the same speed, they should have hit, collided, and stopped. I guess this would be part C? Yeah, part C, when they were sticking together. If they bounced off each other, and the masses are the same, it should have looked like the velocity transfer. So if they're going at different speeds, this one's coming in faster than the other one. After the collision, this one should have been going faster than this one. And it looked like they just basically swapped speeds. Swapped velocities. Now, I know Latoya's not here in order to celebrate what were the new vocabulary word, but we do have new vocabulary here. If they stick together in a collision, we have, instead of saying that, because how would we use those words when we use different ones? If they stick together, this is known as a perfectly inelastic collision. Some textbooks just say inelastic collision. And there's another spiel on that, which we need to talk about energy first, but there's, the wording can get confusing if you go from one textbook to another. A perfectly elastic collision, or, because that's a lot of words there, PIC. Now, in the lab that you did, at one point you basically put a load mass on top of one of the carts, and the load mass is roughly the same mass as the cart, roughly. So if I had some mass M, let's go ahead and use numbers this time, 0.5 kilograms, that was roughly the mass of a cart, heading to the right at 3 meters per second. And I had one that was twice that, so that would be 1 kilogram, heading to the left at, we'll just say 3 meters per second. And they're gonna stick together, so it's a perfectly inelastic collision, or PIC. What is the velocity after the collision? Well, we can come up with some idea of what it is. So first off, P1 initial, or, yeah. What is the total momentum before the collision for this one? It's still up there, so take cards. And we now have established to the right is positive. What's the total momentum of this one before the collision?
-3.
Don't forget the negative. So what is the total momentum before the collision? What's the total after they collide? Yes, should be the same thing. And if they're sticking together, because I said it was a perfectly inelastic collision, well, that's gonna be, I got negative 1.5, that's my momentum, and that's gonna be equal to the new mass, which is 1.5, times whatever the velocity final is. So what is the final velocity?
0 or what?
Closer, or we can do slightly better than just 1. Yes, negative 1 meter per second. So what I would expect in the situation where you had the load mass on top of one of the masses, if they came at each other at the same speed, obviously not the same velocity, same speed, and they collided and stuck together, afterwards they should be going in the same direction that the larger mass was going initially, at 1/3 of the initial speed. Questions to hear? want to do one more thing, then we're going to have a slight shift to the schedule, and then we'll call it a day. Any questions up to here?
Okay, I'm sorry. I know that you like kind of explained this, and it's probably just gonna be easy, but I kind of don't understand how to find the momentum. I mean, it's like, what is it? Between the, wait, on this one, it's mass times velocity. Okay, so
Yes.
when you're getting the, second momentum and the first one momentum, okay, can you like just go over the first part of the problem, of that problem?
All right, so this part right here, is that what you're asking about?
Sure, yeah.
Okay. All right, so momentum, mass times velocity. You're working on your Nobel Prize winning work. That's the formula for momentum then too. This is not a simplification, it's mass times velocity. I can make it look a lot fancier if I need to, but that's it. So when I ask for what's the momentum of an object before the collision, so all I'm doing is I take the mass and multiply times the velocity. It's a one-dimensional problem, so I can get away with velocity by just putting in plus or minus. If to the right is positive, my momentum is just 0.5 kilograms times positive 3 meters per second, which is 1.5, the math part, just 0.5 times 3, and then the units, kilogram meters per second. For the second one, for P2, my mass was 1 kilogram. The velocity is negative 3 meters per second. And so the math piece is 1 times negative 3. And then the units just multiply kilograms times meters per second, or kilogram meters per second.
Oh, okay, I get it.
And then total is just the sum. You add them up.
Thank you.
For velocity, figure, how did you get negative 1?
For, did I get that negative 1 there?
Yeah.
All right, so to get the total momentum, we add the individuals ones together. That's where we got negative, that's where we got, so that plus that is negative 1.5. So, because momentum is conserved, the total momentum beforehand is equal to the total afterwards. So I now know what my final total is. And so that's gotta be equal to mass times velocity. Now, since the two objects stuck together, I now have one big mass. And so that is equal to the final mass times the final velocity. The final mass, while they stick together, I have 1.5 kilograms times whatever VF is. So the math problem I'm working with here is I have negative 1.5 is equal to 1.5 times my unknown.
Oh, okay.
And so you divide it, right?
Yes, if I've got negative 1.5 equals 1.5x, to solve for x, I need to get rid of this 1.5. Since I'm multiplying it, I have to do the opposite by dividing. That cancels out, I'm left with just my x, and on the right-hand side, that's equal to negative 1. Other questions to hear? Kilograms, 3 kilograms, 6 meters per second, and 2 meters per second. This is before, afterwards. We'll have the 4 kilogram mass is moving to the right at 3 meters per second. 3 kilogram mass. Let's make sure that this is actually solvable. Ooh. All right. Probably a bit too early to subject you to that one. So let's make that 1.5. There we go. The problem that I originally wrote up there, what was going to happen is that the 4 kilogram, after the collision, the 4 kilogram mass is going to be going in the same direction as the 3 kilogram, but faster. Which typically, if you have one object hitting another one, it's not, in order for that to happen, that a 4 kilogram mass would have to pass through the 3 kilogram mass. Generally not encouraged in Physics 110. So I changed it to something which could potentially happen. So what I would like you to do right now is to tell me how fast that 3 kilogram mass is going after the collision. I would like you to work by yourself, with the person next to you, whatever seems to work for you.